A black hole isn't a cosmic vacuum cleaner, and it's definitely not a hole. So why can something that isn't even visible control stars, bend light, and warp time itself? Stay with me, because once you understand this, space will never look the same again. The words black hole instantly trigger images of destruction, a cosmic monster, an unstoppable vacuum. But that image is wrong. A black hole is not a hole in space. It's not a tunnel. It's not empty. A black hole is an object with mass, gravity, and structure. The reason it's black is simple. Light can't escape it. And once you understand why light can't escape, everything clicks. But to get there, we have to talk about stars and how they die. Every star is locked in a constant battle. Gravity pulls inward. Nuclear fusion pushes outward. As long as those forces are balanced, the star lives. But massive stars burn fast, and when their fuel runs out, fusion stops. Gravity doesn't hesitate. The core collapses in on itself faster than you can imagine. The outer layers explode outward in a supernova, brighter than entire galaxies. What's left behind is the core. If it's massive enough, it collapses forever. Not into a planet, not into a neutron star, into something so dense that space itself curves around it. That's a black hole. And this is where reality starts to break. Every black hole has an invisible boundary called the event horizon. Cross it, and there is no coming back. Not because you're destroyed instantly, but because escape becomes physically impossible. Even light, the fastest thing in the universe, fails. From the outside, objects falling in appear to slow down. They freeze, they fade. But from their own perspective, they fall straight through. Time and space swap roles. Forward becomes unavoidable. At the center lies the singularity, a point of infinite density where our equations collapse. Even Albert Einstein believed this couldn't exist. The universe disagreed. But here's what most people don't realize. Black holes aren't chaotic monsters. They're surprisingly calm. Black holes don't wander the universe swallowing stars. Gravity depends on mass, not fear. If the sun instantly turned into a black hole with the same mass, Earth would continue orbiting normally. Nothing dramatic would happen. Black holes are only dangerous if you get extremely close. In fact, black holes are some of the most stable objects in existence. They anchor galaxies. They organize stars. At the center of almost every galaxy, including ours, there's a supermassive black hole quietly holding everything together. So if they're not destroyers, what makes them so special? The answer is time. The stronger the gravity, the slower time moves. Near a black hole, gravity becomes extreme and time begins to stretch. If you watched someone fall toward a black hole, their clock would slow down compared to yours. To them, time feels normal. To you, they almost freeze. Near the event horizon, seconds for them could be years for the universe outside. This isn't theory. This is tested physics. Black holes don't just bend space, they bend time. And that leads to a terrifying and fascinating question. Imagine you're falling toward a black hole. At first, nothing feels strange. No sudden pull, no instant destruction. If the black hole is massive enough, you wouldn't even notice crossing the event horizon. Behind you, the universe would appear to speed up. Stars would age. Galaxies would evolve. Then, gravity stops being gentle. Your feet feel stronger gravity than your head. Your body stretches, longer, thinner. Physicists call this spaghettification, not because it's funny, but because it's accurate. And the scariest part, this isn't science fiction. The math works. Physicists aren't obsessed with black holes because they're mysterious. They're obsessed because black holes shouldn't exist. According to quantum physics, information can never be destroyed. But according to black holes, it might be. That contradiction creates a paradox powerful enough to break physics in half. On one side, gravity and spacetime. On the other, quantum mechanics. Both theories work perfectly. Both are proven. But inside a black hole, they contradict each other. And when two perfect theories disagree, it means something deeper is missing. That's why black holes are studied so intensely. They aren't just objects, they're clues. A black hole isn't a monster. It isn't a void. It's gravity pushed to its absolute limit. It's what happens when the universe tests its own rules and reality barely holds together. Black holes challenge how we understand time, space, existence itself. They're not rare, they're not distant, they're fundamental. Without them, the universe wouldn't look the way it does. Black holes remind us of something powerful. The universe doesn't owe us intuition, and every time we think we understand reality, there's something out there bending time, breaking rules, and pulling us closer to the truth. Question for you. If you could observe a black hole up close with zero danger, would you? Comment your answer. And if this video changed how you see the universe, watch the next one waiting for you right here.